This is your main metering jet nozzle. Okay. This is your venturi. This is a venturi.
Oh, I see.
The venturi. And this nozzle is right in middle of that. When you install it like this, it is exactly coming here in between. You install it here. Okay, here. Okay. They put it here. It is exactly in the middle of the venturi. You know, economizer, enrichment economizer. Where is it? Is here. This pump is here. Enrichment economizer. I am not removed from here, so I brought one extra. Is here. Now this is the well. Can you see? Now this has got a hole here. Can you see here? There is a hole here. This float bowl is always full of fuel. This float bowl is always full with the fuel, right? So fuel will go in from this hole and will be held here in this much quantity. This is here. Now this is connected, linked to the engine throttle.
Right.
So when I am giving a push, suddenly I am increasing the RPM to high RPM. Your fuel will not be enough. It will lag before the suction is increasing and fuel is sucked. That will have some lag time, right? It will lag for momentary. So that time when this push, it is connected to the throttle. It is linked to the throttle. It push. Fuel from here, from this well will come here in parallel to main metering nozzle. This is main metering nozzle, right? So the fuel which was already held here in this tank here, normal condition when I am flying at cruise or low speed, this is like this. And when I am pushing throttle, it is going to push it down, all the way down. All the way down. So what was the fuel here, that little quantity, it has come from here and it has not allowed it to lag. Means momentary lagging was avoided by this extra fuel from this accelerator pump. Okay.
So in the float chamber, there's a thing called float, right?
Fuel.
That was connected
This
to
float.
that.
This float.
That's the one. Okay.
This float. This float is, okay, now this is the float. Fuel is coming from here, this fuel inlet.
Yeah.
From the tank or pump, whatsoever. Okay, tank, okay. Now, when this bowl is full, this will go up, and then there is a needle valve here. Can you see? There is a needle valve here. This valve.
Is
this
that connected
needle.
to this?
No, that is I'll tell you later on. So this needle will go and sit, and it will not allow further fuel to enter from here. So if
Not
you are,
until the fuel goes down, right?
yeah, when it is going down again, normally during flying all the time it will be open because you are consuming the fuel. Some little bit open, not fully, little bit open all the time. So when you stop it,
Stops.
and the pin goes and sit in the seat, and it will not allow any further fuel into it. Now if that is damaged, your fuel tip is damaged, your seat is damaged, this will overflow.
Right. Keep
It will
filling it
overflow.
up.
Yeah, flooded. It will be flooding into the engine. Okay?
What is this one again?
That I'm coming, wait. I'm just trying one word. So fuel has gone here. It has entered in this fuel well or fuel bowl. And when it is full or something here, 1 by 8 inch below this will close it fully. When fully closed, that pin goes and sit on the seat, and it will not allow any further fuel to come into the float bowl. Right? Okay. Now, then I told you about the economizer, this jet. So this accelerator, when you are excelling from cruise to high power, you need immediately some fuel, because this suction sensing will take time, 5-6 seconds or so. Till then, you will not get the power. But pilot wants to pull up. or he wants to go fast. So this fuel will be pumped out from here, and this is having supply from this hole. Can you see here, all of you? From this hole, this well will be always filled here.
Yeah, I see it. Yeah.
So, and this will in cruise position will be up here or not lower RPM. Throttle is back, it is pulled out. When you take the throttle back, it is pulled out. When it is pulled out, again you have got a hole here, fuel goes in. Fuel goes into the well and it is filled. Again when you put the throttle forward, gone. It will come out from this jet, this place. It will not come from here. Okay? Right? Got it?
Right.
Okay. Now, this has gone. It has not allowed lagging of the engine. It has immediately given the power because you pushed the some extra fuel and it is gone. But when you are flying and you are going for a higher RPM for a little longer period, you need more fuel again. Why? Why you should have more fuel? Now this started working. It is giving enough fuel for your high power. But still you want to add some fuel. Why? This has picked up. The suction has increased and this is giving enough fuel for high power. This will give. Then why you want some extra fuel? Because I told you, right, when you go at higher RPM, engine gets heated very fast. For cooling of the engine also you want the mixture to be reached. You want some more fuel. When you are going at high RPM for a longer period, consistently, say I am going for 6 minutes, engine will get, temperatures will go like this. So you want some more fuel, because when more fuel, evaporation, it will create cooling. Now how that will come? Here.
Economizer?
Can you press this and see this hole will align with another hole here? Come on. When I press it in,
Oh, yeah.
okay? It is here, it will come into another hole, will align. Now this, can you give my glasses please? Thank you. So what happens here, there is a valve, there is a pin inside. That will open this hole. When you press it in, it's going to open that valve, ball valve there is inside mechanism, which will open this, and oil is always coming from here. So some oil will keep, fuel will keep going again and again inside. From this hole, it will go all from here, and it will go to the engine. Extra fuel from here all the time, so that it don't heat up the engine. So it is accelerator economizer. So again, when your throttle is back, your fuel is reduced, and this is again filled and ready for next increase, right? Okay. Now what is this? This is mixture control. You are only controlling the, what do you call, fuel. Air is coming, that's all. So here, this, you see this sitting in this position. Now look. Now in this position, it is closed. No fuel is going. Now shut off position, shut down. Shut off position. You see. And now when I turn it, see it is opening. See this, there is a slot here, cut away portion. You see? Side cut off, cut away.
Oh yeah.
And here also it has got a cut away, right?
Oh, yeah.
So same here also cut away. In this one, at the back, bottom. Now, when in this position, I have put, now fuel cannot go. Fuel can not go. But now I open, now fuel will,
Right.
the slot is open. You can increase or decrease the fuel.
So the control for this one is connected.
This is
to
your mixture
to the
control.
cockpit.
Mixture control means fuel mixing. Air is not under your control. Okay. So now I can open it partially or I can open it fully, and it will increase or decrease the fuel flow. This is mixture control.
Does that get controlled by the, what is it, the FedEx?
Mixture control. No, FedEx is not here. FedEx.
Is that
Oh.
connected in the
These are all
cockpit?
ordinary
So-
normal engines that you use on 150 or something like
So-
that. So now this is fuel control unit. Fuel control, okay, assembly. Now this is used when you want to shut down the engine, you cut off the fuel. I told you aircraft engines are not cut off with the ignition switch. They are cut off by stopping the supply of fuel. Shut down the fuel, and then fuel will not go, engine will die and stop. Okay, we call in a language of aviation, engine will die. So it will shut down. Okay, why it is so? Suppose now I have turned off the ignition. So there is no spark, right? Immediately when you put off the magnetos, there is no spark in the spark plug. If you turn off the ignition switch, then there is no spark going to the spark plug. But engine was running at say 1000 RPM, it take another 20 rounds, 50 rounds to stop it.
Just fill up with fuel.
Right.
So it will keep sucking the fuel. Fuel is available.
Fuel more and more.
So it will be flooded. Your cylinder will be flooded with the fuel. And you don't want, because when you next time you start, it will not start. It will give you a very hard start. And it can even make a hole in your cylinder, a piston. It's very dangerous. Hydrolock is a very dangerous thing. It can make a hole in your piston, or it can bend the connecting rod,
Right.
or sometimes cylinder can be thrown out of the pad, crankcase. So you don't want that to be flooded, so cut off the fuel supply, not the ignition. In your car, when you put it off, it's gone, done. But in aircraft, you are turning the engine off by cutting the
Cutting
fuel
off.
supply off, whether it is jet engine or this engine or that engine, right? So that is done by this. And now I am going a slow speed. I open this little bit, so little bit of fuel will go. I want to increase some more, will go, fuel will go, more will go. Okay, that is done by this guy, fuel mixture control. Okay, this is your main mixturing nozzle. This is your accelerator economizer nozzle. Here.
So this one, it's gonna come out of here, right? It's gonna come out of there?
Yeah, it will come out there.
And is this not a cutoff too?
No, this,
That's for the-
this throttle.
Okay.
Look,
That's for the.
This throttle.
I see now.
Okay.
okay, and this pump is having connection here somewhere on this one. When you assemble this, I brought broken one. These are all different from different carb. I brought it just to show you guys, so that when you do it and when you go with the manual, you should be knowing what you are looking at. So here is your idle jet. This is idling jet. Idle jet. When you're starting the engine, there is no air passing in this venturi. So there is no suction. There is no suction, do not suck any fuel from here. But you need a fuel to start the engine. Is it? So this hole, can you see small? That will give you fuel from there for starting the engine. So this is idling jet. It will give you some fuel. So start the engine. But once it is picking up, then main metering will take care. Main metering nozzle works all RPM above idling RPM. Up to idling RPM or shut off, this is not working. When you go any RPM above idling RPM, this comes into action. Right? Got my point?
Right.
So that when I am asking you, you are going to answer me everything. Okay? So that is one. Now, I was telling you all the adjustments are, like this, spring loaded screw or nulled nut like this, nulled. null, right? So you can grip and turn it, right? So when you are doing this adjustment, now I am adjusting by pulling it out. Okay, now my RPM has come all right. I leave it like that.
Don't you want to go back a full turn? and
No,
then forward
you
a full
take
turn?
some more out and then put it to correct RPM so that
Okay.
you spring under tension. But when you are leaving this, now it is coming off, so it can start even further something rotate, it can rotate. So always final adjustment on any of these controls, like this control especially, should be done in a tightening direction. Remember this. Got my point?
Yeah.
You should be able to relay. Now throttle. So you understood all the parts now?
Okay.
Any questions? No question? Very good. Sit down.